Alrighty, thanks everybody for coming to our 11 o'clock talk. So B-Sides Pittsburgh just wants to take a moment to recognize our premier sponsor, TerraSwitch, and then our diamond sponsors, Security Risk Advisors and Defy Security. Thank you so much to all those organizations for helping to make B-Sides Pittsburgh happen this year. So I'm pleased to introduce our next speaker, Will Dormann, who will be presenting on a topic called Death by Thumb Drive, File System Fuzzing with Cert BFF. So a little bit about Will. Will's been a software vulnerability analyst with the Cert Coordination Center since 2004. His focus areas include web browser technologies, ActiveX, mobile applications, and fuzzing. Will has discovered thousands of vulnerabilities using a variety of tools and techniques. So without further ado, please welcome Will.
All right, thank you. You guys hear me okay? All right, good. So, the legal stuff required by our company. A little bit of background information about how I ended up getting here. If anybody's ever heard of a filing system called FreeNAS, it's actually pretty slick. I got a server in our server room. It's got 40 hard drives on it. If you ever want an operating system to intelligently use a large amount of hard drives, FreeNAS is great. ZFS is great. Basically, FreeNAS gets you that. So, a little background. We've got a FreeNAS server. Has anybody here heard of a program called Rufus? Yeah. So, right, it's pretty popular, and I think it's quite useful. Back in the day when you wanted to install an operating system on your system, you burn it to an optical disk and you would put it in your optical media drive and go from there. The problem is modern computers don't have optical disks. So what Rufus is really slick at is you can just have an ISO file that you downloaded and you can burn it to a thumb drive. So assuming you have a computer, you can boot from a thumb drive or USB drive. It'll allow you to do that. So at some point in time, I needed to do like a clean install of FreeNAS. So I had my FreeNAS ISO, and I have my virtual machine that has Rufus in it. Paranoid folks such as myself always do everything within a virtual machine because we don't trust anything. So I'm basically, writing the ISO to the USB drive. Wait, that's not right. And my initial thought was, well, I guess maybe there's a hardware problem with my thumb drive. So I go back and I rewrite the thing, and I now have a thumb drive which will crash Windows 7 every time. Reproducible. And this is not me trying to do anything clever. I'm not trying to mangle anything. I'm not trying to be super hey, I'm gonna trick Windows into crashing. No, I have FreeNAS. I wanted to boot off of a thumb drive, and we end up with this. So I'm gonna give you guys a little secret to my success, if you consider me successful. Vulnerability discovery is often considered to be this magic sort of skill set that only crazy people that can do assembly in their head and everything like that. No. There's 3 steps. How to discover vulnerabilities. Step 1, use systems. I think we got everybody covered here. Step number 2, notice anomalies. So when I had my Windows system blue screen, I thought, that's not right. It shouldn't do that. I just wrote bits to a USB disk. And then the final step is just investigate those. And I will tell you, I think that's the one thing that sets aside people that are vulnerability researchers or security researchers from people that are using the systems as tools, is that when something odd happens, I have this part of my brain that makes me wonder, why did this happen? This is basically it. And I'll say, I'll get into a little bit of some of the fuzzing work that I've been doing, but a lot of the cases, a lot of the vulnerabilities that we've been able to discover is really just looking at systems and investigating things that don't behave as you expect them to be. So just a little bit of background about the Cert BFF. It is a mutational fuzzer. And the concept of a mutational fuzzer is basically you start out with a known good or known bad, but basically you start out with a file. Let's say we have a Word document, and it goes into our mutation fuzzer, and it shakes it up a little bit, and you've got something that looks pretty close to a Word document, and then you get that, right? That's your end goal of fuzzing, is you're looking for program crashes. Does anybody here have a BFF? No? Yeah. Sorry, it is not best friends forever. It's the basic fuzzing framework, and it was about 10 years or so ago. There were some tools that were out there, like the Peach fuzzing framework, and you needed to have a lot of information about like the type of file that you're fuzzing and the structure of it, and you would have to write something that tells you how am I going to fuzz this. My goal was to write something that's easy to use. It's maybe like 10 years ago or so at this point, 8, 10. Started out as like a very simple like Perl wrapper around a utility called Zuff, which just kind of mangles things, runs a program, and looks for signals. It's since actually gotten a lot better, bigger, works on multiple platforms. But the general idea of how it works is basically you start out with what we call a seed file. In most cases, it's like a known good file. So if I'm fuzzing a PDF reader, I want a pile of PDF documents. And what the fuzzer will do is it will mangle it. Sometimes we call it like bit flipping and stuff like that, but it really is very, it's naive, but it's basically you take a byte, take some subset of bytes in a file, flip them to some other random byte values, and just see what happens. You launch the target application and you look for crashes. And out of any time something crashes, it's got some tools that come with it that kind of give you an idea of exploitability, and you can get a little bit more information about what the crash is all about, and you repeat it. That's it. It is not rocket science in any way, but it is really vulnerability discovery through brute force. One of the, I'm talking about servers in our server room, like one of the things that we have are like systems that are set aside that just have a lot of CPU cores. And I will set up a fuzzing campaign on as many VMs as I have cores and RAM available, and then you just come back later. I might come back if a target is really fruitful. I might see something that comes up like within minutes. I've seen stuff where it's like within the first 10 or so iterations of a fuzzing campaign, I've seen exploitable vulnerabilities, and now that's a sign of like a really poorly written target app. In some cases, it's a lot more robust. So you can kind of get a sort of a smell as to the quality of the software that you're working, just based on how robust it is to file fuzzing. And the idea with BFF is, like I described before, it's really just taking byte values and changing them to other values, but it's got some feedback loops where it will look for techniques that cause crashes, and it'll kind of steer itself in ways to like know how much do I mangle a file before I get something that's interesting. So without getting too far into the technical stuff, and hopefully this isn't going to be too much of an eye test, but this is an example output of our tool running on Linux. It's fuzzing a library called Oracle Outside In. Oracle Outside In is a great target because it's this Swiss Army knife of something that decodes just about anything. It has over 500 different decoders in it. It can basically give you like a thumbnail rendering of like a document, a PDF, a text file, whatever you want. It's used in a lot of products. It's used in forensic software. It's used by a little product called Microsoft Exchange. It's kind of an important sort of tool. But there's actually a tool that comes with BFF called drill results. So if I just run this tool/drill results script, it'll give me a screen like this, and it'll rank the crashes. And if I ever see something that's like ranked as like a 10 or a 5, that's like, this is really cool. So I look here, I can see I've got a crash that has an exploitability rank of 10. And I can look right below it, and I can see I've got a return access violation accessing some 64-bit pattern. But it also tells me that byte pattern exists in the file that I fuzzed. Interesting. We're feeling lucky. What if I go in my hex editor and I like look for that byte pattern and I change it to something like A, B, C, D, E, F, G, H? This is just a GUI debugger that comes with our BFF virtual machine here. But I can see we've actually got a return to A, B, C, D, E, F, G, H. And I can see that value in the stack. So it's like, here's a great example of a home run fuzzing output. I've just started a fuzzing campaign. I've waited enough time, and then I come back, and then basically this stuff trickles up to the top. So that's the basic gist of fuzzing. So we released BFF years ago, and I like to think that, you know, at the time that we released it, there wasn't really a good, easy-to-use fuzzer that you could just point at something and not have to know, like, what's the structure of a PDF or anything like that. And so we ended up releasing the source code for BFF onto GitHub. And due to the magic of open source software, we got a pull request, which is cool because it's like, here's a little toy project of mine that like I wrote years ago. Not only are people using it, but some guy saw it and said, you know what? I would like it if you added 2 features. 1, I would like for the ability to copy a file to a fixed location. And 2, I would like to also, this came in the same pull request, I would like to be able to run a program for each iteration. So a little bit of information about like why is it important to copy it to, why would anybody have the need to copy it to a fixed location? Certain targets that you fuzz, it might only open a file from a fixed location, right? And so this is an example from a fuzzing campaign of like where the temporary file, you know, for every iteration it does, it mangles the file a bit, it puts it in a directory, and then it cleans it up when it's done. Now, if I'm ever working with something that opens a file from a fixed location, that's not going to help. So with this pull request here, there's a new configuration option called copy fuzz2, and I can basically say, okay, for every iteration that the fuzzer does, I will copy it to this specific location. So if I modify my bff.yaml file, I can now say, so for every iteration, I will have a copy of my mangled file in a fixed location. So that's kind of neat. That'll get me, I've fuzzed some targets that did actually open files from a fixed location, and this will help solve that problem. The other part, this post-process fuzzed option is, it's a new feature that allows you for every time after you've mangled a file, you can run an arbitrary program. So in this particular case, it's just user local bin post-process. But the output of that is, every time a file gets mangled, BFF will run whatever I tell it to run. It could be a binary, it could be a shell script, it could be a bash script, depending on what platform I'm on. So, the magic of these two options is when you put them together. So, with those options together, I can run a shell script to do whatever I want with that file that I just mutated. So I'm basically relying on BFF to take care of the file manipulation, and basically, you know, it's relatively straightforward. But it's the whatever you want part that is interesting, and that's what got us to this particular state of doing file system fuzzing. I thought for a bit here. I was like, you know, so if I go back to me trying to create a Rufus bootable thumb drive, I thought, well, okay, here's the standard FreeNAS 11.2 ISO. It crashes Windows 7. Part of your brain that like wonders is, well, what if I intentionally tried to get Windows to crash? Can I do that? And so that's where I got into fuzzing file systems with BFF. Normally with BFF, you're just going to fuzz a particular target application, say Microsoft Word or something like that. What I started to think about is now with these two enhancements with this pull request, I can do whatever I want. I can create a script called test disk. So for example, if I'm on like the Linux platform, and you don't have to really like look at the specific details here, but this is like a copy of what I was doing on the Linux platform here. And one of the things that I noticed is like sometimes, I'm working with virtual machines here, sometimes when you boot a machine, a Linux machine, I noticed that like its root disk, sometimes it's SDA, sometimes it was SDB, depending on how the planets are in alignment and stuff like that. So in my test disk script here, I just do a simple verification of like which one is my root disk, so I know which one is my USB disk. And here's where the actual like file system fuzzing comes into play. So I have a disk image that I'm starting with. You can just use DD to create a disk image. It could be various file systems. What I'm doing is I'm now taking this mangled file system binary and I'm DDing it to my virtual disk. And then block size 10 megs just to make it like not super slow. When you DD bits to a virtual disk, Linux doesn't know necessarily if anything has changed about that disk. So if I'm fuzzing a file system and I flip some bits in the partition table, it's now going to present itself differently to the computer. So in my shell script here, I just run a command called partprobe, which basically says, hey, Linux, go read the partition table of this particular disk. And then I'll mount it. And then I'll run the find command, which basically is just, in some cases, just mounting a file system might cause something to be bad. But what I want to do here is incrementally do things that trigger a little bit more of what is an operating system doing with the file system. So the first thing I do is I mount it. The next thing I do is run the find command. And all that's doing is that's walking like the file system table. So it's kind of saying, what files are on the system. And then the last thing I do is I try creating a tarball of it. So not only is it, you've got 3 different stages here. You've got the mounting of a file system. You've got the walking of the file system tree. And then you also have the reading of the bits that are supposedly in these files on the file system. So by doing all of these together, and then finally at the end, I can unmount it, So you have a whole sequence of, here I've got a malformed file system, and I've got one script that is doing like the things that would happen like if you like plug a thumb drive in your computer. So basically you run BFF, and eventually you might end up with something like that. In a lot of Linux systems, you won't actually see that because like it kind of hides that stuff visually from you. At the point that your kernel panics, you're not necessarily in a video mode where it's going to like give you this information. So I had to do a little tweaking to just get you to see it. But eventually you got a fuzz, or eventually you've got like a kernel panic there. Windows, I do something very similar. Any virtual machine I have that's Windows, I like to be able to do stuff from the command prompt, and like I want my GNU utility. So Sigwin, it is what it is, but like if you really need like GNU like utilities on a Windows system, it's been how I achieve that. But we basically do the same thing. We're doing DD. On Windows, I'm running a command called diskpart. The odd thing about the diskpart command is it doesn't accept command line parameters that tell you what you want it to do. So if you were to look at that file called rescan.txt, it just has the word rescan in it. So like it's odd that you can give it a file parameter, but you can't just tell it what you want it to do. I open Explorer, I run the find command, I kill Explorer. I think at this particular time I wasn't necessarily doing the tarring and everything like that, but it's a similar sort of thing where it's like you have a mangled file system and now you open it with Windows Explorer and then eventually you get that. So cool. How about macOS? Some of us use Macs. We do a similar thing where I'm checking for the root disk. Macs, it's really just a different syntax for different operating systems, but here I've got something called disk-util. I do some unmount, I DD, force. All right, I think I have maybe a typo in there. That should be a mount or something like that. But basically, you do a sequence of commands. You have a mangled file system, and then eventually, you get your prize. The end here is like, let's be able to potentially crash all these different operating systems. Now, what do we do if we want, so like when your computer crashes, what do? Reboot it and you move on with your day as if nothing happened and, hope that it doesn't happen again. Curious folks might wonder, well, what did I do to get there so I can either don't ever do that again, or perhaps maybe I want to look at the crash to figure out, is there anything I can do interesting with this? So let's start with our friend Linux. I had a little bit of trouble. I'm not really great with computers. I'm going to admit that. And I'll say that Linux confuses me sometimes, right? So I basically have a Linux system, and like the Linux operating system crashed. And I was like, well, how do I attach a debugger to like the kernel, right? Like if the kernel crashes, that's the core of your operating system. How do I go and analyze that? And I found an interesting quote here. It's a little bit wordy here, but this is basically, I happen to believe that not having a kernel debugger forces people to think about their problem on a different level than with a debugger. I think that without a debugger, you don't get into that mindset where you know how it behaves and then you fix it from there. So if you don't have a debugger, you get to understand things on a different level, which is, that's cool. That's a really interesting way to think about stuff. It's kind of a justification for like, why don't we have a kernel debugger? And then he writes, because I'm a bastard and proud of it. Who would write such a thing? Oh my gosh. Yeah, so cool. And this was in a thread where somebody was saying, I really want a kernel debugger. And it's like, I'm not a coder. I can't write anything in C. I have to Google how to do a hello world. However, I'm interested in investigating a crash. Maybe that didn't fit into Linus's idea of, well, a debugger is a crutch that nobody should ever use, and people get really lazy when they have these crutches. There's a link for it if you guys want to. Anyway, I think these slides will be available at some point. Well, it turns out you can do crash debugging if you have like a serial port. Eek. Ugh. It's slow and unreliable, and like I didn't have a lot of fun with it, right? But what you can do is, sorry that print is so small, but basically you set properties you set your baud rate for your serial port. Here we go. We're gonna really transfer data very quickly, and then eventually I get this crash, and I can see a backtrace here. What's kind of interesting in this particular case here is I've got the instruction pointer somewhere where it shouldn't be. These are like the sniff tests of like something's probably pretty cool here. If your instruction pointer is ever somewhere where it shouldn't be, the program will crash, or if it's the Linux kernel, the whole Linux operating system will crash. This is the sniff test that like lets you know that you're on the right track to something interesting. It should never happen. Well, after a little bit of digging, so like I was doing the serial port stuff, and it's a pain. Like I hate it. You have to have two virtual machines, and then the two machines can talk to each other over this serial port. It's a virtual serial port, but it's not very fun. I ended up finding a package called Linux crash dump. The serial stuff is too much work, and so if you just use your favorite search engine, you can search for something called Linux crash dump. And the way that this works is kind of magic, right? Well, I use the term magic, but it's kind of cool. The point that something happens in your kernel where the kernel crashes, the operating system cannot do anything else safely. So that blue screen that you see on Windows, or that panic screen that you see on Linux, like that's actually done in self-defense, because it knows if I were to continue going, if I do anything else at this point in time, I might trash your data. And it's basically, I'm going to stop right here, and I'm not going to allow it to continue. The cool thing about the Linux crash dump package is it is an additional kernel that is loaded into your memory. So assuming you have enough memory, what this will do is, at the point that your kernel crashes, it jettisons the old original kernel and it launches the new kernel. It's already in memory, so it doesn't have to read disk. It doesn't have to do anything that requires drivers or anything. So basically, at the point that your kernel crashes, it now starts a new kernel. And now that new kernel can do pretty much whatever it wants. I was working on Ubuntu 18.04. One of the problems I noticed is that it just doesn't work by default. And this got me wondering. It's like, well, don't people look at kernel crashes? Am I really like in some area that like is untouched before? Well, it turns out like you can go ahead and edit your grub file and like by default. So I'm installing the Linux crash dump package that comes with the Ubuntu package manager. It just doesn't work. You have to manually go ahead and say, okay, I want to set aside more memory for this separate kernel, and then it'll work. So got that. The other cool thing about the Linux crash dump package is you can modify this file, and you could tell it to like put its files on like an NFS server. And so basically, I just edit this file, and I just basically say, okay, well, I'm going to put the panic file on this NFS server, but I also want the file system that caused that panic, so I can associate it, right? So I just modify this file, and I do a DD, and now I have a disk image. So here's like a little silly animation of like what happens when you're doing the fuzzing. On the left side, I've got some number of virtual machines that's only limited by the computer resources I have. And it's placing files in an NFS share. But what I've got is a script that's periodically looking for duplicates. So this is kind of cool because I can start my fuzzing, I can come back later, and I have a pile of what is deemed to be unique crashes. And I just come back later. It's great. If you can do that, if you can set it up in a way that things are automated and you can come back, that's pretty cool. On Windows, I actually use the utility, which is also very cool, called Virtual KD. It works both with VirtualBox and VMware. And basically, when you modify your Windows system to load this driver, this helper driver, it will go ahead and it will spawn WinBag. And I can now, for a running Windows system, I've got a debugger attached to it. So the moment that something bad happens, I will see it. And I can run bang exploitable. I can do whatever I want in this virtual machine. And the virtual machine is doing the fuzzing. And I can see, well, it's kind of an eye test here, but I can see it's complaining about exFAT. It says invalid boot sector checksum. Checksums are the enemies of fuzzing because flip a bit and your checksum's no longer valid. So I might not have really actually exercised exFAT too much. But why stop at one? You know, like the system I was running it on had like a number of cores, so I just do one for each one of them. And then eventually, I can now, in my debugger, I can load this Microsoft debugger tool that tells me about exploitability. And I can see I've now got a crash here, and it says it's exploitable. It's a write access violation in kernel memory. The kernel can do whatever it wants. If I've ever got a write access violation in kernel memory, it's potential that that might be something that could be leveraged to do something interesting. Let's go to our friend macOS. Well, it turns out macOS has some guidance on how to set it up for kernel debugging, which is relatively straightforward. You basically install the macOS kernel debug kit. That gives you a debug version of the macOS kernel, and it also has like some symbol files and some other things like that. And you can do this thing to update the NVRAM, and essentially in your virtual machine, everything here is through virtual machines. You know, you can't. I really wouldn't want to fuzz things on an actual live system, but you boot the virtual machine, and it basically says, hey, I want to use this kernel debugger. The neat thing about the kernel debugging in macOS is I can connect to it with like TCP. So I just give it an IP address, and like I can now interactively. So when a crash is encountered on the macOS, I can run our friend LLDB, our debugger. I tell it KDP remote, and then I give it an IP address. So at this point in time, it now connects to that particular system, and I can do a backtrace. And I can see information about my crash. I can see right here that I've got panic trapped to debugger. So I've actually encountered a kernel panic in like the traditional sense, in that like I see a call to this panic trapped to debugger. I can see the source code that caused the panic. I can see NTFS collate in NTFS version 94, line 102. Then at the very end, like it actually doesn't tell me where that code lives, because when you install the macOS debugging kit, you don't actually get the symbols for all of the drivers because it would be an enormous download, so they give you the prime ones. But I'll tell you, that frame lives in the NTFS kernel module, which you can kind of tell because of the frame above it where it says it's in, you know, it basically is giving you the panic string. That's not the actual code there, but it's just telling you, hey, I've got a panic. Now, I was thinking for a little bit, wait, panic? Why would there be a panic? This is the code. This is NTFS version 94, and I can see a line here where if this data length is less than the size of the file name attribute, I call the function called panic. This is not a surprise to anybody at Apple. Nobody has thought, well, okay, I did something wrong and I now have a crash. They basically said, in the code that we have running in kernel land, I'm doing a check, and if this check fails, I'm going to panic the whole system. In the NTFS code. Now, the reason that somebody would panic, I had mentioned before, is you panic so that you don't cause further corruption in a system. Yeah, you can see the panic here. When something happens in the kernel space, you don't want to trash your files. It could be an access violation in the kernel. It could be an explicit call to the panic. But the thing that I was thinking is, this is in NTFS code. Your macOS will never be running off of NTFS. So why is it that if it ever encounters a corrupt NTFS file system, it causes a panic? So I kind of shrugged about that. I was like, well, maybe don't panic. I mean, like, I told Apple that I think they're going to be fixing it. I don't know if they're removing the panic from it or just fixing the bug. I call it a bug because, like, you know, you're using a computer system. The operating system should never crash. This isn't the Windows 95 days where you look at it funny and the whole thing blue screens because it's all in the same memory space and everything. So I started to think about attack vectors. There's a YouTube video. If you probably use your search engine to find death by thumb drive, you'll find this. And I basically go through and I demonstrate plugging it into a Windows system, a Linux system, a Mac system. It's all the exact same thumb drive, which, if anybody is feeling lucky, if they think they have a computer system that's not going to auto-mount file systems, I will happily lend this to you for a couple seconds while I watch to see what happens. But this is the very thumb drive that happened here. But basically, your three major operating systems, and I think I threw in a FreeBSD just for the hell of it, and they all crash. Almost all of them were in NTFS. I think with Linux, it ended up being like RiserFS and JFS. One of the things that you'll know that, like, with like an Ubuntu system, you get a lot of stuff by default. If I look at the file systems that Ubuntu supports by default, it's got archaic stuff, right? And then RiserFS, it's not under development. You know, the guy murdered his wife or something. You know, don't do that. But it's still there. Like, when you get your Ubuntu system, it has that code there, and it's in kernel land waiting for whatever. Now I started to wonder, okay, well, so if you have physical access to a computer, you kind of win already, right? Like, we wrote a vulnerability note on it, like, years ago that basically said if you have physical access to a system, that might violate some sort of protections that you have in place. But I wanted to dig a little bit deeper. What can you do without having physical access? Because, you know, if I'm touching your computer and I can cause it to crash, all right, that's cool, but I could also just knock it off the counter, and, like, you're just causing vandalism. So I started thinking about Macs. Well, and it turns out all my disk images were .dd files, and, like, Macs don't do anything with .dd files. But if I rename that to .dmg, it just handles it in the same way as, like, it were a disk image. So that's kind of cool. So if I'm the attacker, I'll rename my disk image to .dmg. One of the things I noticed is that Safari, I think Chrome even does this. I hate that they do this. You have to turn this off, please. If you're using a web browser that auto-downloads stuff, turn that feature off. Apple decided at some point, they're like, you know what, I'm going to open safe files after downloading. This is this checkbox in there is a little bit different because at some point in time, Safari did actually open DMG files automatically. So if you're downloading a disk image, it would mount that for you automatically, and stuff happens. Luckily, they've changed that behavior, but they still download the file in the first place. So all the user needs to do is, I'm visiting the website, all of a sudden I have a DMG in my downloads, and what happens if I double click on it? Anybody want to guess? Yeah, so we just crashed the whole operating system as the result of double-clicking a file that just ended up on my system. It shouldn't happen. It makes me feel uncomfortable about how computers work. How about Linux? Linux is a little bit different. I'm surprised that I'm going to say this, but like Linux is actually a little bit safer with how it handles disk images. In that, I would need to, after I download my disk image, I would have to say, open with other application, and then I manually choose disk image mounter. I couldn't find a file extension that just actually mounted it as a file system. But as soon as I click that and I hit select, all right, all my work is gone. Hope I saved my Word document that I was on. Let's go to the Windows end of things. It turns out there's a capability in RDP. It is optional. But there is something called remote FX, which allows you to do USB device pass-through. The cool thing about that is like I might have like a two-factor authentication thingy jig, and I don't have to worry about like, does my RDP client understand that, and is it going to do what it needs to do? It's basically just saying, hey, I'm going to convey what's in my USB port, and I'm going to allow it to connect to that remote system. The thing about this that's not really great is, yeah, it's optional. And it's only for authenticated users. So you're limiting your attacks to like, it has to be an authenticated user, and it has to be on a system where they've decided, I want the ability to do USB pass-through. But, I tried it, set up a virtual machine, did the USB pass-through, and boom, Windows 7 crashes, stop in the NTFS. But I started to dig a little bit deeper. And it turns out, if you have a disk image on Windows, you can take that disk image and you can turn that into a VHD file. And that's basically like a disk image format that is used with Hyper-V, which is like the default hypervisor. It comes with Windows 10 and Windows 8 and later and stuff like that. The cool thing about this is like this tool, it turns out a VHD is really just the same thing as a DD disk image with like a little bit of metadata at the end appended onto it. So it really, this VHD tool doesn't do anything super clever. It just like puts the stuff at the end that Windows is looking for. So let's imagine on Windows, we've downloaded this VHD file. It's either emailed to us, and we double click it. Anybody see a theme here? What happens after you double click it? It crashes your computer. It doesn't prompt you. It doesn't say, hey, would you like to open this file that you just downloaded from the internet? So like, I wish it didn't do that. So I had a question here. So like the VHD stuff, and VHDX is like a modern version of VHD. I was wondering, are there security products that scan with inside of VHD or VHDX files? When you have like an email server, it's going to scan zip files. It might scan even more obscure like archive formats. But I started to wonder, and I did a little search, and does anybody here know if you have? Does anybody know of a product that scans VHD or VHDX files? Let's say theoretically there is one that exists. What does that mean to us? Well, whatever's doing the scanning, if it's parsing VHDX files, it's probably parsing the file system within that file. Maybe that scanner is going to crash. Well, let's say, what if they don't scan VHD files, which I think most of them do not? You have to be aware that, like, here's a file format that you have zero visibility into. When somebody emails you a zip file, you've got all these tools that keep you safe. You spent lots of money on it. VHD is kind of interesting here. Now, there's another thing that I mentioned earlier about when you download a file from the internet, Windows tags that file with something called the mark of the web. And this is basically a piece of metadata that says, hey, this came from somewhere dangerous. Email, internet, web browser, something like that. So here's Microsoft Word. If I open up this Word document, it says, hey, I've opened this in protected view. It runs with like low privileges, like lower than even like a restricted user. So basically, it keeps me safe. But how does it know that? How does it know that they came from the internet? Well, it turns out if you open up a command prompt here, I can do dir/r, and it'll tell me like this metadata. This is an NTFS metadata sort of thing, and I can actually see here. Here's a zone identifier, and if you want to, this is kind of neat. You can actually just run Notepad, and you can open that file, and it tells you exactly, like, here's where this file came from. Zone ID 3 means it came from the internet, somewhere sketchy. Starting with Windows 10, they actually put like the URL from which the file was downloaded. So like, it's kind of cool from like a forensics perspective, in that like, if you have a bad file on your system, you can tell where it came from. So any download that you have, and this is through email or anything like that, well, email, I have to figure out what, like, how it indicates that. But if I download something with a web browser, it tells me, okay, this came from attacker.example.com. So that's kind of neat. Now, let's say I have this document that I downloaded from the internet, and I get this button here, and it says, enable content. This is just the proof of concept that I have, all right, and runs calc, right? Very simple sort of stuff. Mark of the web protects you from that just by giving like one additional click that no user in the right mind would ever possibly click, because they understand the consequences of clicking it, right? That's how it works, I think. Well, let's think about mark of the web and VHDs. So the mark of the web is actually applied to these VHDX files. I showed in the prior slide. It's there. So the mark of the web is there. So it's applied. The problem is that Windows doesn't treat a downloaded VHDX or VHD or VHDX file any differently than it otherwise would be. And I get the impression that security devices don't really scan VHD files or VHDX files. What can we conclude from that? VHDs and VHDXs are pretty interesting. From an attacker, if I want to deploy, if I want to deliver my malware to any organization, I'm going to put it in a VHD. Now, you have to be running Windows 10 to be able to just double click on it. Windows 7 can, like, you can manually mount it, but it's like no end user is ever going to fall for anything in a VHD or a VHDX file. But if you're on a Windows 10 platform, that's an excellent vehicle for bad stuff to come in. So, finally, just to kind of wrap things up, and I'll open it to if anybody has any questions, or if anybody wants to try out my thumb drive, I'll happily loan it to you. I promise that I have not done anything to cause this thumb drive to do anything permanent to your computer, like running malicious code, assuming you trust me. So, just a little bit back to fuzzing with BFF. In like the standard way that you're running BFF, where I'm running a target application, it has a capability that I like to think of it as atomic iterations, which is not like some awful prog rock band name or something. It's actually, what that means is every time I launch my target application, it either crashes or it doesn't crashes, and then it goes away, and then I start right over again. So every single iteration of a fuzzing campaign exists in isolation. BFF itself will automatically deduplicate crashes. So if I'm fuzzing a target application, BFF will determine which ones are dupes, which ones I've seen before. It will also do exploitability determination. It does something called crash minimization, which is kind of neat because, like, let's say I'm fuzzing a Word document and I get something that causes a crash. If I happen to manipulate 100 bytes of that file, it could be that, like, there's only 1 byte that caused the crash. So BFF will automatically determine what's the minimum amount of file manipulation that will cause that same sort of crash. String minimization is the thing that helps exploit developers in that, let's say I start out with a Word document and it crashes. If I do a string minimization of that, what that'll end up doing is it'll replace as many bytes as possible in that file with the Metasploit string. So basically, it'll say any bytes that don't affect the program's ability to open the file and then also crash in the exact same way, I'm just going to replace it with, like, the Metasploit string. So as I'm looking at that file, I can say, okay, these are the byte values I can change to whatever I want. This stuff is all pretty cool, and like BFF has done this for years. Like, it's a free download. It works on Windows. macOS, and Linux. So if you have any interest in fuzzing, I would recommend go try it out. It's found, like I've used it to find a lot of vulnerabilities, more than I could possibly count. And it's found vulnerabilities in things that matter. Like back in the day, like when we developed this fuzzer, because like software was like, I will say that when we developed it, software was lower quality than it is right now, because people have, like your folks like Microsoft have built in checks into the compiler. They do things automatically. They ensure that people don't do silly things. But we've been able to find exploitable vulnerabilities in like Adobe Reader, Adobe Flash, Shockwave, any Microsoft Office. We've been pretty productive with it. Now, the problem is you don't get those benefits when you're doing anything OS level. When I have an operating system that's running and I tell it to do something and something goes weird in kernel land and it keeps doing that over and over again, that operating system continues to run for the lifetime of that fuzzing campaign. So I might be doing a fuzzing campaign and eventually the operating system crashes and I'm like, oh, okay, cool, it's that last thing that it did that caused the crash. Not really, because you have an operating system that has been running for that entire lifespan, and it could be that one of the iterations that I did flipped a bit in kernel space and it didn't do anything bad. But then like later on when it did like some heap cleanup or some other stuff like that, it caused it to crash. So you have cumulative effects. You have to do manual crash deduplication, which I kind of described a little bit like in the case of Linux where it's putting stuff on an NFS server. I can look at those back traces and see which ones are duplicates. The exploitability determination, yeah, it's kind of like me as a human being. Oh, Linux, well, yeah, I think in all of the cases, in order to determine exploitability, I kind of had to sit down at the crashes. And they are the unique crashes, so it wasn't like a ton of work, but it was manual. And then the whole crash minimization and string minimization stuff, you can't do. Because you're running BFF on an operating system. And if the operating system crashes from underneath BFF, like it's not running anymore. There is no more BFF. So on to the recommendations. Here's where I tell you things that I think you should do, but I know are not really practical. It's what we do at Cert. For the sole reason that later on, when something bad happens, I can go back and say, I told you so. You didn't listen to me. And just think, I just want you to, if anything, just think about this for a little bit and get the right mindset here. Unless you're absolutely certain your operating system doesn't auto-mount file systems, don't plug in an unknown device into your computer. Now, it's great advice. It keeps you safe. Now, everybody's always in a situation where like you need to, let's say you're in training and they pass around a thumb drive that has like your stuff on it. You kind of have to do it. Turns out macOS, Ubuntu, Windows, they all auto-mount drives. So if you're using a popular operating system, it's auto-mounting stuff. When I was creating this crashing thumb drive, I had to use like a special Linux distro or Linux windowing environment that doesn't auto-mount anything. Now, here's my follow-up. Even if you know that your computer doesn't auto-mount file systems, don't plug unknown devices into your computer. And the reason is, I've only looked at file systems contained within USB mass storage. USB does a little bit potentially more than that. The other recommendation that I have is, if you're running an email, if you're running an enterprise, and you see a VHD or a VHDX file get emailed to you, block it. There is no reason ever for any of those files to get emailed to you. Usually they're very large because it's the entire disk of like a server or an operating system. That would be an easy thing to block. And if you have like a proxy or something like that, maybe somebody, if they're working with Hyper-V and they have a specific reason to download it, maybe they'll need that. The other thing that I mentioned earlier is that remote FX stuff. If you have that turned on, I'm not saying to turn it off. I'm saying reassess your organization's need to have remote effects. You might need it, but just understand that by turning it on, you might increase your attack surface. And then finally, just to kind of wrap things up, I don't know if you've ever been at a security conference where you get a USB-powered thing. Does anybody know what this does? I could probably even cut the cable of that, and I could see there's only a red one and a black one. It's power only, right? There's been some research where people have been able to embed inside of the USB connector, like a microcontroller. So imagine you, as a normal human being, you've received this at a security conference or some other conference, or maybe you found it in a parking lot, and you're like, oh, cool, free lava lamp. Don't plug it into your computer. Plug it into your friend's computer, or friend's computer. It's very difficult to know without necessarily a scanning electron microscope and a decapper and other sort of stuff. You don't really know what might happen when you plug stuff in. Here's my contact info. I think we're about right on time. So we at Cert, we have a blog. We occasionally talk about some interesting things. I've got a Twitter account where I often talk about not interesting things and sometimes interesting stuff. So, ta-da. Does anybody have any questions, comments, short debates? Yes. So that was actually, it's a very good question. And the question is, just to generally summarize it, is it possible to do something, oh, sorry. I might have misinterpreted your question. So one thing would be, can you put it on an Android device where maybe you plug your Android phone into something? Yeah, you can absolutely do that. You can have your Android device do anything. The other thing that I looked at that I thought maybe you asked was, is there a file system that Android operating system contains that I could crash Android? And it turns out Android only has 2 or 3 file systems. They don't have RiserFS, they don't have JFS in there because nobody wants it. And just as I've looked at different Linux distributions, this is a difference that I noticed between, for example, Red Hat Enterprise Linux. It comes with XFS and ext4, and that's it. If you want something else, F you. Ubuntu, on the other hand, it's hey, we got everything. Here's something that was made a long time ago, but it's turned on by default. So, any other questions? Anything? Yes? Oh, right. You could go back to the supply chain aspect of things and see well, here's the thing that I bought from Apple, but who manufactured it for them? And how do I know? It's does it have that seal of authenticity? I'm very, I'm inherently paranoid based on where I work, but also with the things that I've seen. I really, I do kind of follow that advice of, and I was thinking earlier here, I'm doing this presentation, I'm what if they give me one of those clickers, right? They give you the clicker where I can walk away from my computer and well, that's a thumb drive. It's a USB device that you've plugged into your computer. So it would be quite ironic if I had accepted a clicker to do this presentation. So I'm mechanically typing my keyboard. Thus, the life of anyone interested in security. You make the trade-offs. I don't have a good answer for that. I don't know, how do you know what to trust? I don't trust anything. Does that help you sleep at night? I don't know. Anybody else? All right, thank you. Oh, wait, I got one quickie. If you want to see something quick, if my screen comes up here. As I was putting together my PowerPoint presentation here, I encountered an odd behavior. And here's my I don't understand how computers work at all, right? I have no clue. So I've got this title slide here, right? And I just found out that it's a widescreen format sort of thing. So it's oh, I gotta change it to a widescreen, and then so I copied my slides over. But this font was too big, so I went to make it smaller. What? Let me replay that again. Look at what text I selected, and when I select a smaller font size, look at what text gets smaller.
The beauty of Office.
This is why I have a job. Software is terrible. Software, terrible software is what ensures that I get paid. Not for this. This is the thing that just annoys me when I'm trying to put together a presentation to give it a conference. But anyway, software is awful. Don't use it.
Enjoyable office.
Yeah.
Here's the payoff.
Okay, cool. Thank you. Thank you.
Alrighty, and Black Track will resume at 12:30 p.m. in this room with lightning talks. Have a good lunch.